All right, so now we're going to be moving into section 11.8, and what we're going to be studying is a very famous mathematical problem called an optimization problem. Optimization problems are usually situations where we're trying to maximize a situation or minimize a situation. And several examples coming across from many different areas, but if we were in business, right, as a business person, I'd be very interested in maximizing my profit, right? What's going to make my profit a maximum? How much money can I bring into my company? Of course, you would think that the more we produce, the more profit I would make, but that's not always the case because more often than not, we are constrained. I hope I spelled constrained right. By something, right? So what is, as a company person, what are we constrained by? Well, we're constrained by cost, right? The cost of the material. We're constrained by the pay for my employees, the time that my employees can actually work, right? It's kind of unfair. My employees, we as human beings can, probably work for a good maybe 9-10 hours, but we start getting a little tired. So we need breaks and we need to move around. And so perhaps I move in shifts, but again, more employees means more costs. So I would love to make my profits as high as that I can make them. But when we think about the cost of material, the amount that I pay my employees, my budget basically, right? Because, I only have so much money that I can actually pay my employees, pay their healthcare costs, pay them for their time, pay for material. We're limited by a budget item, right? Or all these things. And so based off of all these constraints, how much money can my company make? So there's an example of a maximum of a profit. Sometimes in terms of minimize, sticking with business, I want to minimize my cost, right? We want to make the cost as minimal as I can, but still, there's still some constraints with the cost with regard to what we're constrained by. Am I going to be renting a facility or do I buy a facility? All right, whatever the case might be. For those who, the energy costs that we have, right? Those tend to fluctuate from time to time. Do I have solar panels or not? Right? So on and on and on. So the cost of the material, again, how much it actually costs the material will also impact the cost and how to minimize that. So again, a business model. It doesn't always have to be business. Perhaps what we're trying to do is take an area, a geometric shape. So we've got a rectangle with some certain length and some certain width. And what I want to do is minimize the area. Of course, we know area to be length times width. However, we are constrained, right? The thing that's basically constraining us in this case is the amount of fence that we have. And so that would be the perimeter, right? The perimeter is twice the length plus twice the width. So perhaps, right, I probably have so much fencing that I can use, right? Maybe we only have 1,000 feet of fencing. So if I'm constrained by how much fencing I have, then of course it's going to impact, right, the area that we create in terms of what is the maximum area that we can make when I'm constrained by 1,000 feet. All right, so those are basically optimization problems. We'll see quite a few more as we move through this section, but that pretty much nails down what we're going to be trying to do. We're going to be trying to maximize or minimize a situation, right, given some sorts of constraints. All right, so we at this time have studied quadratics, right? And as far as quadratics are concerned, they are fantastic for optimization problems. As we saw in earlier chapters, quadratics, right? So something of the form ax squared plus bx plus c, when we graph these, their graphs are parabolas that are opening downwards, all right? Or they're parabolas that are opening upwards. And you can basically see, right, if we can mathematically model my profit, my costs, my area, whatever situation I'm trying to maximize, if we could mathematically model it with a quadratic function, then its corresponding graph is going to be a parabola, And then hence to find the maximum or to find the minimum, we're in essence just basically trying to find the vertex. And of course we know how to find the vertex using modified completing the square, just simply the vertex formula. So for example, for profit, let me throw some X and Y axes onto this, right? Perhaps the X axis represents the number of units that I've made, and the Y-axis represents the dollars in profit. So as I increase the number of units that I make, like let's say we went from 50 units to 75 units to 100 units, I want to know how many units do I have to make in order to hit that maximum dollar profit. So again, we're looking for a vertex with regard to that. And so there's basically why our study of quadratics are going to be classic functions for optimization situations. All right. And so, of course, now what we got to do is actually go look at some of those situations. There'll be word problems that we'll be doing. We'll be trying to find the quadratic function so that I can find the vertex and hence find the maximum amount needed or the minimum amount needed depending on the situation. All right. So without any further ado, let me go ahead and close this out and we'll start working on some application problems soon. See you in some videos.